So, a quick video on setting up the two adjustments on the Artemis. Now, dawned on me earlier, looking at my other video, the battery light was on this meter. So I have several meters. Dug some others out, and yes, a good job I did, because this was reading a bit off. I especially noticed it when I was cranking up to higher voltage settings. I was getting some weird readings which weren't quite matching. So yeah. So for instance, this resistor at the end there, you know, my last meter, when the battery in this was flat, it was saying there was just over 450 volts on that cap. Changing the battery, it now agrees with my other meters, so that's better. The actual raw supply itself is only just 460. So anyway, there's two adjustments on this. So there's this potentiometer just here, that's the AC bias to drive the grid to the output stage. And there's that one there, which is the potential between the heater supplies to 0V. So if I adjust the heater one, so this is always fun, try and do everything with a phone in your hand. So I'm picking up some noise on the scope. You could just do this with a speaker connected, but so if I go to one extreme, you can see plenty of AC noise on the supply, and if I go somewhere in the middle, it comes down and then goes back up. So basically you just want to adjust that to, it's just finding the sweet spot, and it is pretty much there. And that measures, it is slightly off center. If I go to an AC on my meter and probe the heater supplies, see, one's measuring about 6.5, one's 5.6. So yeah, that's that one. Then other ones, I'm not going to adjust this one because I've messed about ages. So the AC bias on this one, so if I apply a signal, oh, I've gone off the, bear with me, gone off the scale on my scope there. So I'm applying an AC signal. So again, I put this meter on AC, and if I probe the grids on the output stage, 2.1 volts AC on that one, 2.11 on that one. If I start cranking up the volume, let's go down the scale, let's get some, let's crank the output a bit. I've tried this at various frequencies as well, just to make sure. So 10.17 volts AC on that one. It was way off before. 10.17, and different frequencies and that lot. Yeah, you can see there's a black dot there, which is where I've now got it roughly set, and there was a line there. The line was where it was originally set. It was way off. If you actually measure the grid voltage coming into the second stage, so I got 1.88 volts on the grid of 1/2 the valve, and so yeah, it's a small amount off, but it's the output transformer needs to see good AC, so it's the grids of these valves really, not the grids from this one, that want to have the AC balance. There's no point sending a balanced AC signal to here and then having an unbalanced one to the output stage. So yeah, that's the, I've got a 16 ohm load there. I can't run it very hard with that because it'll cook, but yeah, she is now all set up sweet and adjusted. Yeah, I'm far happier. I was going to like put an extra resistor in there, but I'm far happier now. I know that cap isn't actually running at the voltage I thought it was running on. Yeah, these resistors, they get warm, but they're running sweet. So yeah, that one, I'm going to call that one done. That one is very much done. Valves on this take ages to reach their final bias setting. See, they're a bit low at the minute. But again, that was because of this meter battery being low. I was reading that a bit higher than it actually was, so I'm going to have to just retweak them. But as the valves warm up, they start to draw more current, which means the HT supply collapses a little bit. But seeing as the bias supply, the HT supply for the output valves and the HT supply for the input valves are all coming from the same transformer, as the HT starts to droop, as it's loaded up, the bias voltage will start to droop. And bearing in mind, when I say the bias voltage droops, I mean it approaches, it gets nearer towards 0V, so it actually becomes more positive but because it's a negative supply, it's still drooping, which means the amount of voltage applied to the valves to bias them off decreases slightly, so they turn on a bit more, and there's a bit more HT droop, and it slowly cycles through as the valves warm up until an equilibrium is reached. So it takes a good sort of 10 minutes. You'll start off at like 30-40 millivolts, and then about 10 minutes later you're up to the 120 or so across these bias resistors. So, but yeah, at least I know heater noise and AC balance is sorted out on this. It's one of those, you change the valves on this, it all has to be done again. The heater one even will need a slight tweak because there's going to be minor differences in the physical layout of the heaters and stuff in the valves, which is why you have it in the first place. Otherwise you would just have 200 ohm resistors bang across, and it's not a million miles away from its mid position anyway. But yeah, anyway, that is how to set up one of these. And as always, I like to point out where I've gone wrong with things like, you know, don't use a multimeter with a half-dead battery. The reason I'm using this one and not that yellow, and that yellow one does work, it's so slow, it takes forever to refresh. It was a cheapish meter, I just got it because I thought I wanted to replace this one, and you'll put it on something and it's like it's got a refresh rate of a second. It'll just jump up and down for ages until it eventually settles, whereas this one, and even the cheapy meters I've had over the years, you just on work. So seems to be some real shite software in that meter. But anyway, yeah, that is all. I've got to go pull this off the bench and go get the other one and start working on it. So yeah, as always, thanks for watching.